This series of videos is about Fourier transformation and polynomials. We start with polynomials. A polynomial is a special kind of function, such as 4x to the power of 3 minus 5x squared plus 2x minus 1, or 7x to the power of 6 plus x to the power of 3 minus 3. So a polynomial is built from powers of x and real valued factors and plus and minus. The real valued factors are called the coefficients of the polynomial, and the highest power occurring in the polynomial is called the degree of the polynomial. So the first polynomial px has degree 3 and the coefficients 4, minus 5, 2 and minus 1. And the second polynomial has degree 6 and the coefficients 7, 0, 0, 1, 0, 0, minus 3. The zeros stand for the powers that are not here. The general form of a polynomial is an x to the power of n plus an minus 1 x to the power of n minus 1 and so on up to a1x plus a0. It can easily be represented in the computer, so in the program, by just indicating its coefficients. And they are ordered from left to right in the inverse order, as they are shown in the polynomials. So we start with the lowest valued coefficient and we end with the highest valued coefficient. And the t that you see in this vector here means that the vector actually is a column vector, which is just written in as a row, but it should be a column vector. What are polynomials good for? What can you do with them? Polynomials have many applications in mathematics, in physics, in engineering, and in many other sciences. And I will just show you one of those applications. Let's suppose you have performed a series of measurements. You have measured, for instance, the temperature of some object at different times. Now you have those 5 points here, and you see that you've forgotten to measure at the point with the x-coordinate 2. There's some point missing here, and you would like to know which could be the point that would be fit in this series of measurements. We would not expect to be the point here somewhere or here somewhere. We would expect it in this region here. But how can we do this? The problem of finding such points is called the interpolation problem. And there's one very common method for interpolation, which is interpolation by polynomials. You use a polynomials to interpolate these points. And there is exactly one polynomial of degree 4 that connects those 5 given points. And this polynomial, I show you here, that's the polynomial of degree 4 that meets all those 5 given points. And now you can guess that the point with the x-coordinate 2 must be here. And this should be this point. This is the missing point. And this method is called interpolation using polynomials.